So what did we do yesterday? Started u-substitution. No, it's alright. Alright, so you guys always want to, when you're walking up to the problem, you always want to rewrite first, right? So you always want to put constants on the outside and rewrite. So, what's that? No. Yes. I heard it's like National Pancake Day too. So. Well, how would you rewrite it? Right. All right, so does everyone understand why we're putting 1 over pi on the outside? Right, we're dividing by pi, so it's the same thing as multiplying by 1 over pi. Right, and then I can rewrite with an exponent. Now, all right, which would your u function be? All right, so du would be what? Okay. So I don't have 2x plus 2. I have x plus 1. So what am I off by? Divide by 2, right? So if I divide everything by 2, right? I have 1/2 of du is equal to 2x divided by 2 is just x, and then 2 divided by 2 is 1. So if you pick, say, x plus 1, right, as your you just have to look like, all right, if you pick like x plus 1 as your u, right, and then you found its derivative, right, which is just 1, that doesn't help you like replace that piece there. So if I do x squared plus 2x, right, I'm very close to what I have left over. So that's kind of the difference. All right, so this is your correction right here, your 1/2. All right, so when you plug everything back in, you have to put the 1/2 now on the outside. Okay, so I have 1 over pi times 1/2, which is my correction. And then I have u to the 1/3 du. All right, so now all I have to be concerned about is how do I integrate u to the 1/3? Okay, so what does that give me? That gives me 1 over 2 pi. U to the 1/3 becomes u to the 4/3, and then we're going to divide by the reciprocal of our exponent, which would be 3 over 4 plus c. So what does that give me? 3 over 8 pi, and then I have, we know u to be what? X squared plus 2x to the 4/3. Right. Yeah, the antiderivative of u to the 1/3 would be 3 over 4 u to the 4/3, and then you just plug u back in. What's that? Steps. All right, so I would try and rewrite first. So that means like put your constants on the outside. Rewrite exponents. All right, so after you do that, you want to try and pick out your inside function or your innermost function. All right, so the key is when you're picking out your u function, right, you need to kind of do the derivative of them in your head and be like, okay, is that derivative somewhere else in my integrand? All right, so make sure du is present in integrand. All right, so what's next? Replace with u and du. Integrand. So, like this is your integrand, like what you're integrating. All right, so you're going to replace with u and du and integrate. And then after you've integrated, you're going to put your u function back in. What do you mean? What do you mean anti? Right. And don't forget your plus c. Everybody go with that? You go with that, Sen? All right, so evaluate each of the following, each of the following has the same inside function but a different outside function, and hence a different technique of integration. Evaluate each. Okay. All right, so you always want to rewrite. So I got 5 on the outside, sine of 2x e to the cosine of 2x dx. Okay. You got to look for which function would be the most inside function. E? Or is it cosine to the 2x? Well, you have sine. You have a sine function. You have 2x is another function. You have e to something. That's another function. And then you have cosine of 2x. So you really have 1, 2, 3, 4. You have 4 different functions there. So which one is built inside the most, has the most layers around it? The cosine, right? I'm sorry? Yeah. Put it on the outside. So if you were to use like this, right, you just get 2, and then that doesn't really help you with this part. Yeah, right. So this would be, yeah, so you have kind of like 1, 2, 3, 4, yeah, 5. All right, so if we let u be cosine of 2x, then du would be what? So you're finding the derivative now. Negative 2 sine of 2x, chain rule, dx. Right, derivative of cosine is negative sine. Derivative of 2x is 2, right? Okay, so do you have that somewhere in your integram? Right, you have sine of 2x, but you don't have the negative 2. So that's what you have to correct. So you're going to divide that to the other side. So you got negative 1/2 du is equal to sine of 2x dx. All right, so now I can replace this sine of 2x dx with sine of 2x dx. Okay, so when I rewrite my integrand, what should it be? Negative 5/2 integral e to the u du. Good. Right, the u is replacing the cosine of 2x, and the du is replacing the sine of 2x dx. Right? So the integral of e to the u would be what? Just e to the u, right? So then I can just put u back in. E to the cosine of 2x plus c. And then don't forget your constant up front. Yeah, it kind of just goes, once you find your antiderivative of this, like this is telling you, okay, I'm going to find the antiderivative of that function with respect to u. Like this is what you're finding an antiderivative for. Okay. Yeah, so it's a little more, your functions are a little bit more complex than what we would do. Yeah. So this is just like it's like a technique to find the antiderivative. No, this is pretty much all we do is this one. Yeah, so it works a little bit different if you have a definite integral, which we'll get kind of later in the section. And I'll show you guys how to do that if you have a definite integral to work with. Okay. I would rewrite it. Now, cosine squared of 2x is the same thing as what? cosine of 2x squared, right? So if and then I have that radical on the outside. So I really have cosine of 2x to the what? Correct. Okay, good. So again, we're saying that the u function here is going to be the same. So you have cosine of 2x. So du is negative 2 sine of 2x dx. So then I have negative 1/2 du sine of 2x dx. All right, so that's not going to change, but so you have negative 7 over 2, right? And then you have, what would your integrand now be? U to the 2/3 du, right? What 2? Sine 2. Here? Why would it cancel? This is like the angle of the sine, so this is like built inside of the sine function. All right, so now you just have to integrate the u to the 2/3. So you get negative 7 over 2 u to the what? 5/3, and then have your reciprocal out front, and then plus c. So you got what? Negative 21 over 10 cosine of 2x to the 5/3. Let's see. Does that make sense? All right, so see if you guys can figure out C then. So rewrite first so that you can see what you're integrating. Yep, keep going. Without the squared though, it's just cosine of 2x. Because this here, cosine squared of 2x, like you want to rewrite that so that it's cosine of 2x in parentheses and then the squared is on the outside. Yes, ma'am.
Like, if you divide by negative 2, why does this 2 go with?
Because that's built inside of the angle.
So, like, this.
Right. Yeah, so you can't just like.
You can't just take it.
No. Right. Nope, you're good. Yeah. Good. Good. Sure. It's just like a -1, so. All right, so is everybody good with that one? All right, so we have cosine again. Cosine of 2x is your inside function, derivative of that, right? Everything is the same, right? So now I'm integrating u squared, right? Because cosine of 2x is built inside, blob squared. So when you integrate that, right, you add 1, you get u cubed, divide by your new exponent, and don't forget your correction out front. And then just replace back in. Everybody good? Okay, so says evaluate secant squared tan of x 2 different ways. Okay. Sort of. That's one way. Yeah. All right, so Dante said we can rewrite it as secant of x times secant of x times tangent of x. Okay, so this is where you kind of want to figure out, all right, do I have my derivative anywhere? No, do I have, can I group any of these together so that when I take it, something's derivative, it's there? What do I want to put together? Correct. So, all right, so if I let my inside function be secant of x, right? So then du is secant of x Yeah. All right, so we have this present, right? So I really should, what's my integral? If I replace everything, what should it be? U du? Okay, good. So antiderivative of u would be 1/2 u squared, right? And then I'm just going to replace u. secant of x squared plus c. Right? The integral of that is 1/2 u squared, right? And then just replace u. All right. So what way do you want to do it, Mike? So you said let u be okay. I see what you're saying. So again, we still have u du, and you get right. Well, no, actually, we don't get the same answer, do we? Yes. No, it's not squared. Yes. No. It's not going to work. You're not going to get the same answer. Even if you use like a trig, this is technically 1/2 tangent squared of x. So if you even use like a trig identity, you don't get the same answer. So, so I think this isn't going to work because this one is more like the secant is built into more of inside of something than the tangent is. So that's not, it's not going to work. All right, how can you rewrite secant squared? Okay. And how can you rewrite tangent? Okay. All right, now, what if I put them together? What do you get? You get sine of x over cosine cubed of x, right? Now, if you were to rewrite that, how would you do that? Good. So I have sine of x times cosine of x to the -3. Okay, now, out of those two, which one is more inside? Cosine, right? Okay, so then du is negative sine. Okay, so then I just have a correction of -1. Oh, yeah, you don't need that. Okay, so what would your integral now be? If you're going to replace everything, what would it be? Could u to the negative 3 du. And you need a negative 1 on the outside. Good. All right, so when I find the antiderivative of that, right, I get u to the negative 2. You got the negative 1/2, and then the other negative. So you get 1/2 of so we know what's u. What did we say u was? Cosine. So that's really 1 over cosine squared of x, which is really what? That'd be like multiple choice. Like, come up with it any way that you can. That would. Like they would, like, it would just, instead of 2 different ways, it would just say, like, find the antiderivative of that. And then you'd have a couple different choices to pick from. Right. Well, we made secant the inside function for the first one, right? Typically, the rule is whatever function is, like, has more layers to it is usually your inside function. So because tangent of x does not have, it's just tangent. Like, it's not, it doesn't have a layer to it. It's really not the best u function in picking. That's how I would kind of interpret it. So you're saying do like secant squared, like on the outside, times tangent. So secant of x squared, like that. Oh, okay, so if you pick that, right, that would be obviously more inside. When you take its derivative, what do you get? You get secant tangent, which you only have the tangent. So yeah, this is obviously the easiest way. That one's a little bit more difficult, but I don't know. All right, we got time for one more. It's going. You cannot take out the 5. All right, so what are you saying u is? So you get 3x squared as your derivative. That doesn't help you with this or that. It doesn't help you with this. No, I understand that. But when you find its derivative, right, you get 3x squared. So that helps you with that, but it doesn't help you with this 5 to the blob. So you need something a little bit more inside. So I would go with this, 5 to the x cubed plus 7. Not secant squared. So 5. So when you find that derivative, what would it be? It would be that times ln of the base, which is just a constant, times the derivative of the exponent. 3x squared. Right. All right, so I have this, right, is right here, right? I can divide that over. I can divide the 3 over, and that would give me the x squared. So all I'd have to be integrating is just secant squared. This is the derivative of that. Or I'm sorry, this is the derivative of that. I know, that's the, yeah. So, all right, so we got this, there, that, there. All right. So all we have to do now is just find secant squared. So you got 4, 1 over 3 ln of 5, integral of secant squared u du. Now, what function, when you take its derivative, gives you secant squared? Tangent. So you have 4 over 3 ln of 5, tangent of, let's see. Yeah, because this entire thing is u. All right, guys, get some of your worksheet done, please. See you later.